Hello and welcome to this episode of Math with Martinez. In this video for our unit on polynomial and power functions equations and inequalities, we are looking at skill P4, continuing to solve polynomial equations by applying a variety of techniques in mathematical and real-world problems. We've already seen exactly what it means to solve polynomial equations. Those solutions are those values where our function is equal to 0. Graphically, that looks like these points where our polynomial function is crossing the x-axis. We've seen that we can find these values if our equation is a quadratic equation by using the quadratic formula. Now, today what we're going to see in this video is another one of those various techniques. And this is going to be focused on what to do when you're trying to solve these binomial equations. So here's the deal. Pattern recognition is a really key and important part of solving polynomial equations. So we want to have an eye for our polynomials to be written in these ways, because if they are written in one of these three ways as either a difference of squares, a sum of cubes, or a difference of cubes, we can use these patterns and these rules to solve rather easily. So let's go ahead and begin. The very first one that I want to look at with you all is how to solve a difference of squares. Now, what do I mean by a difference of squares? What I mean by that is that we are looking at a term that is a squared term, and subtracted from that is another term that is a squared term. What exactly is a squared term? What might those look like? Well, it means that we need to keep in mind all of our perfect squares. Those perfect squares are just these results that occur when you square an integer value, right? So these are all examples of integers that are perfect squares. So when we're asked to solve a quadratic that looks like this, it should be really evident that, oh, look, we've got 25. 25 is one of my perfect squares. And look, between, I've got this subtraction, and you know what? This is a perfect square as well. Check this out. We can take the square root of x squared, and that is x. Ladies and gentlemen, this is really, if I could scooch this over for a moment, this is our a value. Our a is what is squared right here. What is squared? X is squared. So we have just found our a. Now let's also take a minute to find our b value. The b is the second quantity that has been squared. So in our case, we're asking ourselves, well, what squared is 25? Or the square root of 25 is 5. So we've got our a and we've got our b value. Now, let's go ahead and apply the rule. What is the rule? Well, the rule says that if you have a difference of squares, you may factor it down into these conjugates. These conjugates are going to look like, let me make that a little smaller, almost the same, except that between one, you'll have addition, and between the second, you'll have subtraction. So you take your a value, which for this example was x, and your b value, which in this example was 5. Now you have two linear terms, and you can use your zero product property, set each of them equal to 0, and you'll have your two values that are solutions for this equation. So let's take a minute and highlight those as, let's take a minute and highlight those. These are the solutions to this equation. And for the sake of time, I'm actually going to only do the odds in this video. So that was our example for a difference of squares. But there are more special patterns that we want to be aware of. What if instead of a quadratic binomial, what if we instead have a cubic binomial, meaning that we're working with two terms that are added together, and maybe like this case, added together, and both are cubes. Well, what do I mean by cubes? I mean that they are values that are the result of cubing. Values that are the result of cubing, like all these that I have listed here. These are just the first 10. Of course, this list does go on, but we want to be aware of those first 10. How do we factor this down? What is the rule? Well, if you're dealing with a sum of cubes, it factors down to two factors, one of which is a binomial and one of which is a trinomial. Now, let me kind of just show you with this example here what that would look like. Your A, how do we find that A in the rule? Well, our A is just taking the cube root of your first term. So what's the cube root of x cubed? It is x. And what's that b value going to be? It's the cube root of your second term, which is 125. What cubed is 125? What number cubed is 125? Oh, you know what? I made a little mistake up here. Sorry, it's not 75. The 5 cubed is 125. My bad. Make that adjustment. And then we've got it right there. Okay, now continuing on, let's see, what would this now be? We would need to have our binomial with addition in between. Because it is a sum of cubes in between the first two, we will add. We will take our A value, which is x, and our B value, which is 5. And then in the trinomial, we'll take our A value, which is x, and square it. So it's x squared. Then we'll take and subtract A times B, which is 5x. Then we will add to that our B value squared. So B is 5, but squared is 25. Okay, now we continue. We continue like we did previously. We'll use our zero product property, setting each of these equal to 0. And we will solve. I didn't need to put that in parentheses. So we can solve this first one pretty quick. It's just going to be -5. But for this next part, we're going to need to use the quadratic formula to solve that trinomial. That's what we saw in our previous lesson. So let's go ahead and do that over here. Again, we're not going to actually use this example number 4, so don't worry, you have the rest of this box to do example 3. So here we go. Let's use our quadratic formula. Remember that it's a really good idea to first think about identifying your A, B, and your C value. Let me do something here really quick. I'm just going to clear this off so that I have plenty of space. If you have whiteout, you can white out as well. And if you want to white this one out, you can. And this one too. Okay, cool. Now we're set. Let's keep going here. Quadratic formula. For this guy down here, I'm going to kind of shift colors ever so slightly. You want to identify what is your A, your B, and your C that you're going to use in the quadratic formula. And that's from this guy right here, the a, the b, and the c of this guy. Our a was 1, our b is -5, and our c is 25. Now we're going to plug those in to our quadratic formula. So our quadratic formula is opposite of b plus or minus the square root of our b value squared minus 4 times a times c all over 2 times our a value. Now let's simplify. Opposite of -5 is just going to be a +5 plus or minus. And what is going to be there inside of that radical? Can you guys figure that out? What is that going to be there? You should have a -75, and then that's all over 2. Now, get a little thought bubble here, because remember that whenever you're taking the square root of a -1, what does that actually simplify to? It simplifies to I, that imaginary unit. So we're going to want to rewrite this as x equals 5 plus or minus I. And can we simplify the square root of 75? We sure can. You know what? Let's do that before we even rewrite this. Let's think about, what is the square root of 75 going to be? Remember, what we ask ourselves is, I'm trying to figure out what are the two values. One that is a perfect square, one of these from up above here, one of our orange highlighted values. What's a perfect square that can go into 75? Well, I know for sure 25 can. That is the actual largest. 25 times 3. So what does this give me? Square root of 25 times square root of 3. That's actually 5 square root 3. So we kind of do this in our side thought right here, because now I'm ready to rewrite this. This is actually going to be 5 plus or minus. Now rewriting the square root of -75, it's actually 5. Don't forget the I comes out. And then what's left inside the radical is only that square root of 3. This is all over 2. Then, ladies and gentlemen, to wrap it up, we want to go ahead and write the two answers that we would have here. We would have x equals 5 plus 5i square root 3, and each of these values is divided by 2. But not only that, we also have 5 minus 5i square root 3 over 2. So these are our solutions to this cubic equation that we found by applying a pattern and using our quadratic formula. Now just one more here. It's a lot like the one we just saw, but instead what we have here is, in between our cubic terms, we are subtracting. But the process is much the same. So we try and find our little a value. We try and find our a value, which is to say, what is the cube root of that first term? It's just x. Then we want to find the b value, which is to ask ourselves, what's the cube root of our second term? Not looking at it as a -27. No. It's the b is what is after the value, after that subtraction. So what is the cube root of 27? That is 3. Okay, so now use your pattern. Use the pattern here. We're going to have our a value, which is x, minus our b value, which is 3. Then we're going to take our a value and square it. Add to that the product of a and b, so that's 3x. And add to that your b squared, so that's 3 squared, which is 9. We're solving, so we want to go ahead and let each of these equal 0. That's our zero product property. The first of our factors here, we can go ahead and find the solution there very quickly. It is just 3. But now we're once again going to need to use the quadratic formula again. Let's use our quadratic formula again here. To solve that part. So again, we want to identify what is the A value. What is that going to be? It's going to be 1. Our B value is 3. And our C value is 9. So into the formula we plug opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times our A value. Let's simplify. This is going to just be a negative 3 plus or minus. And what is that going to be inside of the radical? What is that going to be, you guys? We should have a negative 27, square root of negative 27, and that's all being divided by 2. Okay, so let's think about simplifying this over here on the side. I know that this is actually going to be I square root of 27. Now 27, how could I break that down a little bit more? What's a perfect square that can go into 27? That's a factor of 27. 9, 9, and 3. And when I take the square root of 9, it is 3. That other 3 that's in the radical stays in there. And so we have now a way to write this that's much more simplified. It is to write this as, we want to put that 3 and then the I, square root 3, all over 2. All right. Now, lastly, let's write this as our 2 different answers. What are those 2 different values? Negative 3 plus 3I square root 3. Both those terms divided by 2. That's one of them, where we did the addition, where we added, because you know it's plus or minus. So there's one of them. The other is to write it as x equals negative 3 minus 3I square root 3. Make sure both those are over 2. So there's our 3 solutions for this difference of cubes. Ladies and gentlemen, that is all for this video where we were solving special binomial equations using pattern recognition and using the quadratic formula when needed with our cubes. If you had any questions, please would you take some time right now to share those? And until next time, stay fired up.